Okay, in this presentation what we're going to do is look at how to differentiate and integrate terms in the form cos ax, sin ax, and e to the ax. Just some quick examples of what that could mean. Cos of 2x, sine of, let's go something interesting here, sine of pi x, and e to the minus 2x. All those sort of things there. Okay. Essentially, it's a constant times x, and you're getting it's a function upon that. For example, the exponential of minus 2x. So those are just a sort of few quick examples of what we're talking about. We're going to sort of disregard them for a minute and just take a very simple term. Take things in very simple terms here. We're just going to go back to cos of x and sine of x. And what we're going to do is actually just to sort of talk about this little sort of rule of thumb for remembering cosine and sine. Particularly, just watch out for the sines. It's handy to use the tables, but it's just sort of remember, this is pretty handy as well. So, if we want to get the derivative of sine of x, that's cos of x. If we get the derivative of cos of x, that's minus sine of x. Minus sine of x, derivative of that is minus cos of x. And derivative of minus cos of x is minus sine of x. So, essentially, if we are going clockwise around this, we are differentiating, okay? If we are going anti-clockwise, that's integration. So, the derivative of minus sine of x is cos of x. The derivative of cos of x is sine of x. The integral, I should say, the integral of minus sine of x is cos of x. The integral of cos of x is sine of x, and so on. So this is integration going anti-clockwise around this clock, so to speak. Okay, so clockwise differentiation, integration is anti-clockwise. Okay, so let's draw a few more there, a few more hours. That doesn't matter. Okay, so that's just handy to remember for a few of the remarks I'm about to make. So, derivative of cos of ax. Now, if you were to do this by the sine rule, cos of 2x, sorry, the chain rule, if you do this by the chain rule, you would get the derivative of ax, and then derivative of cos of ax with respect to ax. And you get minus a. Well, the a here would be the chain rule component corresponding to a of x. And minus sine of a of x is the derivative of cosine. Okay. So anyway, we have an a here in front of sine ax. Okay. So minus a times sine of a of x. Again, the components are a times minus sine of ax. Something different here. The cosine of ax dx, that is equal to sine ax over a plus c. We just disregard that coefficient. We won't talk about the undetermined coefficient. We won't talk about it anymore. But here we're dividing by a, just to sort of counterpoint. We are multiplying, pre-multiplying by a there. The minus is something else. So when we differentiate, we multiply, and we integrate, we divide by the constant a of x. Okay, just a sort of quick example of that. Cos of 2x dx is equal to sine 2x over 2 plus c. Okay. Actually, I'll just continue that. Derivative of cos of 2x equals minus 2 times sine of 2x. Okay. Right. Something very similar for sine of ax. It's a times cos of ax. And again, the ax, when you get the derivative of that, when we're using the chain rule, sorry, just spell it out here, the chain rule, we get a, and when we get the derivative of sine of something, we get the derivative is the cosine. So it's a times cos of ax. Integration sine of ax dx, get the integral of that with respect to x. That is minus cos a of x. And just actually something I should have mentioned before, actually. I'll just sort of be clear about it here. The underlying principle is the substitution technique. This is for integration now. It's a substitution technique. That's how we know how to check that. I won't do it here because actually the point I'm trying to make is you can take these as an article of faith. The one thing I was going to just sort of re-emphasize here, integrate or differentiate, multiply by the constant, integrate, divide by the constant, and so on. Quick remark about e to the ax. E to the x, derivative of that, or the integral of that first off, is it just itself, e to the x plus c. Derivative of e to the x is again itself. So far so good. But what happens when we have e to the ax dx? Well, here what we do is when we integrate, we divide by the constant, so it's e to the ax over a. We leave it alone, but we just divide by the constant plus c. And when we differentiate, derivative with respect to x of e to the ax, that is simply multiply by the constant a times e to the ax, and so on. So just a sort of quick example on that. Derivative of e to the 4x is 4 times e to the 4x. The integral of e to the 4x with respect to x is e to the 4x over 4 plus c. One more thing I should mention, actually, is when we're dealing with definite integrals. So suppose we have 1 and 0 and we're getting the cos of 2x dx, and that would work out to be what's cosine is the integral of that. That is sine of 2x over 2 from 1 to 0. So that is sine of 2 minus sine of 0 over 2. Something I should just bear mentioning here, we're going to take that to mean radians. So whatever you get in your calculator. Okay, so just as if you're used to working with degrees, for example, let's go back here. So degrees, so 360 degrees in radians, that is 2 pi around 6.28. So 2 is roughly, sorry, actually wrong way around. 2 radians is just slightly less than 120 degrees. Okay, it's probably 110 degrees or something like that. But anyway, your calculator should work on the basis of radians. Alright, that's enough of that.